Hola, mi amigos. I hope you had a great day today. We're going to continue talking about rational functions and relations. Remember, these videos are where I instruct you to learn and to help you learn about these wonderful concepts in Algebra 2. So we're going to talk about rational functions and relations, simplifying, multiplying, and dividing rational expressions. Okay, so we're going to learn how to do those three things and then identify the domain of the rational expression. Very much like the domain that we did when we were graphing them. Okay, so here we go. Remember that functions have polynomials in both the numerator and the denominator. And do you remember when we were graphing a rational function, we would make equivalent, we would factor, and then we would cancel common factors in both the numerator and the denominator, thereby making an equivalent expression. The ones that have the common factors canceled, those rational expressions are in simplest form. Simplest form is when the common factors of the numerator and the denominator have been canceled. So if you look at expression 1 here, notice that I cannot, and I know that we like to and we really want to, but the x and the 1 in the numerator cannot be separated, and the x and the 1 in the denominator cannot be separated, okay? So those are not common factors because one is a plus 1 and one is a minus 1. On number 2, if I were to factor my numerator, I would have x plus 2 times x plus 1 over x plus 3. Notice that I don't have any common factors in the numerator and the denominator, so it is in simplest form. Let's look at some that are not in simplest forms. Okay, these three illustrations are going to have factors in common. All right, so I have an x in the numerator and then an x times x in the denominator. Notice that I could cancel one of the x's in the numerator with one of the x's in the denominator. And when I did that, like that, then I could say 1 over x is in simplest form. There's our reciprocal function, by the way. All right, notice with number 4, I have an x minus 3 in the numerator with this same x minus 3 in the denominator. So what do you suppose I could do with those? I can cancel them because they are identical. And so an equivalent expression to this first one would be just 3. 3 is going to behave just the same as 3 times x minus 3 divided by x minus 3. Okay. Number 5, we're going to factor the numerator, and we're going to get x minus 3, x plus 2. Remember, if you need help remembering how to factor, I put that video out there for you. And then x plus 2 times x minus 1. All right. And so notice now I can cancel this x plus 2 in the numerator with this x plus 2 in the denominator, and my original expression, the one that's typed in there, is equivalent to x minus 3 over x minus 1, except for the fact that this expression here cannot take on the values x cannot equal negative 2 and x cannot equal 1. Okay? So you have to make sure that your domain corresponds or must be the same as the domain of the simplified expression must be the same as the domain of the original expression. Okay? So the way to ensure that you do that is to factor But before you cancel, you want to state any values that will create like either a whole or an asymptote, i.e. exclusions. So if we were to factor this one again, we would have, I'll go back to purple, x minus 3 times x plus 2 over x plus 2, x minus 1, and those would cancel. And I would get x minus 3 over x minus 1. And then I would look back at my original before I crossed out, and I would have said x cannot equal negative 2 or 1. So my domain would be all x's such that x cannot equal negative 2 or positive 1. Okay? So probably you want to, like I set up in the text, you probably want to make note of that before you actually cancel. Why don't you try the video question, and then if you don't get it correct, then mark down what you did, and so we can talk about it tomorrow in class. All right, so now we're going to simplify each rational expression, just like what we were doing in the last couple of slides, and we're going to state the domain. We're going to state any exclusions. Remember to state your exclusions before you cancel. So on number 7, this is my numerator is going to factor into x plus 5 and x plus 2 over x minus 5, x plus 2. So what are my domain restrictions? Well, I know that x plus 2 is going to cause a whole, so I have to exclude that. So all x's such that x cannot equal negative 2. And 5 is going to cause a vertical asymptote, so x cannot equal 2 or 5. Now I get to cancel. I'm going to go back up here and I'm going to do it in red like that. And then my equivalent expression, x plus 5 over x minus 5. There's my equivalent expression as long as my domain is this. Okay? They're equivalent as long as the domain is the same as the original. Okay? So you try the video question here. Notice that we don't have any plus or minuses. So you're going to use the rules of exponents. This is a little different. Rules of exponents. Okay? You're going to subtract the exponents of like bases. Okay? State your domain and your range before you do any canceling. Factoring is not needed because these are monomials, okay? So we can just cancel and factor just like, we don't have to factor because we can just use the rules of exponents. All right, here we go. My domain are all x's such that x cannot, that should be all x's and y's. Such that x cannot equal 0 and y cannot equal 0. Okay. Now, when I cancel with monomials, I just apply the rules of exponents. 24 divided by 6 is negative 4. X cubed divided by x squared. X cubed divided by x squared is x to the first. Y squared divided by y cubed is y to the negative 1. So I get negative 4x over y. Okay? So when you're factoring and you have binomials as your factors, okay? Make sure that you notice that 3 minus x can be written as the opposite of x minus 3, like this. You can factor out a -1. What that's going to allow you to do is cancel more factors, okay? Okay, so now we're going to multiply. Let me go back. Okay, now we're going to multiply. So the thing to do is factor first, then state the domain restrictions based on those factors and cancel any common factors out, okay? So x squared plus x minus 6, okay? Well, that's going to be x plus 3 times x minus 2. It has to multiply to -6, add to +1, 3x minus 2x. All right? Now, instead of having this separated, I'm just going to put all of my factors that are in the numerator on top and all the factors in the denominator on the bottom, because that's what it means to multiply. Okay? This factors to, this is a difference of squares, if you remember, or you can just say what two numbers multiply to -25 and add to 0. Well, that's going to be x plus 5 and x minus 5. And then this one, this bottom one, x squared plus 4x plus 3. What two numbers multiply to +3 and add to +4? Well, that's going to be x plus 3 and x plus 1. Okay, now state your domain restrictions. You have to have an exclusion for every single one of these factors in the denominator. So we have all x's such that x cannot equal -3, -1, and 5. You don't have to have them in that order. They just go from smaller to greater. But this one produces x can't equal 5. This one produces x can't equal -3. And this one produces x can't equal -1. Now I get to cancel. So I get to cancel this x minus 5 with x minus 5. I get to cancel x plus 3 with x plus 3. And now what remains as an equivalent expression, x minus 2 times x plus 5 over x plus 1. Now I want you to try the video question. If you didn't get it right, make sure you write it down so that you can ask me about it in class tomorrow. All right, now we're going to divide. Okay, lots of the same process. However, remember that dividing by a fraction is the same as multiplying by their reciprocal. Okay, so let's factor first. So I have 2 minus x over, that should just be a plus there, x plus 1 times x plus 1 divided by, notice that I'm not drawing one big long line for division, x plus 5 times x minus 2 over, this is the difference of squares, x plus 1, x minus 1. Okay, so let's state our domain restrictions. I can't have a +1 or a -1. So far, and I say so far because things change with division. So x can't equal 1 or -1 so far. I'm not making my full statement yet. Now, this keep, change, flip. That's because multiplication by a fraction is the same as division by a fraction is the same as multiplication by its reciprocal. So watch what I do. I keep the first fraction, rational expression, just the way it is. Keep 2 minus x. Actually, I'm going to factor out a -1 from there. This is an example of that. So let me erase this right here. I'm going to factor out a -1, and that becomes -1 times x minus 2, okay? And then I have x plus 1 times x plus 1. Now, change means take this division and make it a multiplication, okay? And then flip means take this second fraction and flip it. X plus 1, x minus 1 goes on the numerator, and then x plus 5, x minus 2. Note any new domain restrictions. Notice that now I can't have x can't equal -5 or 2. Okay? And now I get to just cancel where I can. All right? So I'm going to cancel in red. So I have an x plus 1 here and an x plus 1 there. And then I have an x minus 2 and an x minus 2. I still have my -1. So now my equivalent expression with all, in simplest form, with all the factors canceled out, is -1 times x minus 1 over x plus 1, x plus 5, as long as my domain is all x's such that x cannot equal -5, x cannot equal -1, x cannot equal 1, and x cannot equal 2. Okay? So then we're going to try that video question. Remember, if you get it wrong, write down what you did, and then we can talk about it in class tomorrow. This will be our daily assignment in our book. And so if you feel like you need to do a couple of them just to shore things up with what we learned, what I taught you tonight or whatever time you're watching this, then please do that. Thank you so much for listening.